Hello class, welcome to our lesson for section 2.3. This deals with the topic of histograms. What we're going to look at is what a histogram is, what it also is not, and how to set one up and how to use some programs on your homework to help with some situations that may show up as you move through this chapter. Okay, the first question that we're going to look at deals with blood type. Now we've kind of looked at this information already before. This question you'll notice says create a bar graph based on the data. So what we'd probably do here is figure out how many people have type O, type A, type B, and type AB, add up those numbers and figure out how many in each group, and then just make a bar for each category. And it would look something like this. Now I arrange them from highest to lowest, so the most is type O for this case, and then A, and then B, and then AB. Okay, but this is a bar graph. It's categorical data, it's split up, okay, and you're just saying how many in each group, and it's just a visual of representing that idea, which is similar to kind of a frequency idea if you were in categories as well. What we're looking at is not typically going to be a bar graph situation. So bar graphs is based on categorical data, and the main visual difference is that there's a gap between these because these are just categories, like this is US, India, UK, etc. Whereas a histogram is based on the frequency distributions that we did before, and that was always a range of data. So it was like 40 to 49, 50 to 59, etc. Okay, and there's no gaps in these bars, and the reason is because there's no gap in the numbered line. Okay, so when we're looking at these situations, what we want to remember is a histogram, no bars, and it's a number range because it's just a continuous number line and saying how many are in each of those categories. When you're looking at a histogram, okay, you might see some, you might have to create some, you might have to interpret some things. Okay, so for like this one here, this is going from 100 to 149 and then 150 to 199, 200 to 249, 250 to 299. Those are those frequency distribution pieces, and then the frequency is how many are in that group, and that's where the histogram comes from. So it's essentially just taking your frequency distribution and making it into a visual format of the histogram. All right, so one of the main purposes of a histogram is to make sure that we can figure out if, in fact, the distribution is a normal distribution, or what type of distribution that we're looking at. Normal distribution is what we're going to be looking for most often, which is the bell-shaped curve. Okay, that's also known as symmetric distribution. It should start low, go high in the middle, and end low. Now, when you look at this scenario, what you'll notice is it's not perfectly symmetric. For example, this bar here is not the same height necessarily of this one. Okay, the second one are different, third ones as you move forward. It's not saying that it has to be perfect. So look at the highest one then to the left and right. Those clearly aren't the same, but they're close to each other when you look at the big picture. Now, some of you are going to be really struggling with this idea because you want it to be symmetric and perfect. Okay, data is not perfect. It's not going to be. So you want to look more general. Okay, so think kind of zooming out a little bit. Does it look like a bell-shaped curve? Does it look like the hill? Okay, going up and then back down. That's what you want to look at for a histogram with normal distribution. Okay, so skewness. Skewness is what we were just talking about. So symmetric, bell-shaped curve, normal distribution, those are all the same. Okay, I put in this mean, median, mode idea just to showcase that you've learned mean, median, and mode in other classes, and you probably haven't used them for much except for, oh, I know how to find the mean, I know how to find the median, I know how to find the mode. Well, in actuality in statistics, what the goal of this is to figure out where things are located or what type of skewness there is. And so if the mean, median, and mode are all approaching the same thing, what that probably means is there's not a lot of data on the two ends, and most of the data is in the middle, which is the bell-shaped curve or normal distribution. That's one version of skewness. The other two versions of skewness are skewed to the left, or negative skewness, and skewed to the right, or positive skewness. Students typically mess these two things up because they look for where the hill is, but it's where the tail is, where the valley is. Okay, so skewed to the left, negatively skewed, has a longer tail to the left. And what it's saying is that the mean and median are lower than the one that occurred most often. Okay, so the mode here, it doesn't matter which is first, mean or median, but the mean and median are lower than the most. What this could be is something like a test grade. Everyone did the average, and the one that occurred most often was higher, but maybe there's a few low scores that really affect that average that bring it down. So when students say, what's the average? And I tell them, they say, man, that's a horrible average. Well, what I didn't tell them is that there are two students that have zeros right now because they haven't taken it. Okay, so that those two zeros bring the average down, even though the most students still did better. Okay, and so this is a left skewed or negatively skewed graph. Skewed to the right or positively skewed has a longer tail to the right side, which goes towards the positives. Okay, this is where the mean and median are higher than what occurs most often. Okay, so this would be the same idea of, oh, what's the class average? And a few people got really good scores, and so the class average looks decent, but most of the students are actually under that class average. This same thing can be true in many of the sports that you play or activities that you're a part of. If you do something that's abnormal compared to the norm, okay, it's going to throw off that data a little bit. Okay, so negatively skewed, tail to the left. Okay, more data to the right. Skewed to the right or positively skewed, tail to the right, and then the more data on the left. You want to make sure you have those two things figured out along with bell-shaped curve, because you're going to be asked questions about that as you move through your homework and your testing situations. Okay, speaking of homework, most of the questions on your homework give you a frequency distribution and say what histogram matches up. There are ways to do that on the program called StatCrunch on your homework assignment, but honestly what you should just be looking at is each bar should represent the groups from like 40 to 49, for example, and then 50 to 59, and then just say how many are in each of those groups, and just kind of estimate and say, oh, it's supposed to be 5, so it should go up 5. The next one should be 10, so it should go up 10. I think once you get the hang of that idea, that's what I would use for those situations. I think that's the easiest option as you're looking at it in order to be successful on that type of question. You won't have to create the histogram yourself in many cases, but it's just using the table and then the corresponding frequencies in order to figure out what the correct solution is to those problems. The other thing I want to show is not that you need it right now, but as you move forward, is how to make a histogram using the program called StatCrunch. Now, what you should notice on your data is if there's any sort of data in your homework assignment, and you bring it up, there should be like this double rectangle here. If you click that and you hit open in StatCrunch, it should open up what looks like to be kind of like an Excel file look to it, except there's some other applets and buttons at the top that you can use. Okay, so hitting the double box just inputs the data into StatCrunch, so you don't have to type it all in yourself. Some students try to use like Excel and other programs to be able to type things in. Your best bet is to use the program embedded in your homework for some of those questions in order to get some good responses for those scenarios. To make a frequency distribution, you'll and the tables, the buttons I think look a little bit different because each update is a little bit different. But if you select Stat, Tables, then Frequency, okay, Stat, Tables, Frequency, it'll bring up something that looks like this frequency table. You just want to make sure you click the one variable that you have, and then if you want frequency or relative frequency or cumulative, okay, those pieces would be all there, and then you hit compute, and it should spit out the frequency distribution if you need it. The same thing could be done with a histogram. Okay, so to open up a histogram, you would hit graph, okay, and go down to histogram. You would select the variable that you're looking at, which probably only has one column, so there's only one option there, and then you hit compute. And then you would be able to see where the data is looking for that situation. That is also a similar idea about scatter plots. So eventually we'll get down to 2 sets of data, okay, and we'll be looking at that scatter plot idea a little bit in the next section. But you can graph a scatter plot by taking the data, opening it in StatCrunch, graph scatter plot. You just have to make sure that variable 1 is one thing and variable 2 is the other, so you can see what the scatter plot looks like. Honestly, it's more trial and error. I would test out some of these StatCrunch pieces. It's not really vital to this section, but might become more useful as we move forward. You are going to have to use that program StatCrunch in order to be successful on a lot of your homework questions. So you want to make sure that you're able to open that, at least input the data, and see if you can figure out how to make something like a frequency distribution or a histogram based on the data that's there. Again, that's probably not as useful for this lesson because they're kind of giving you the frequency distribution, and you can just set it up. That way it's already kind of ready for you. You just have to look at the bars and say how high the bars are based on the frequency numbers. But as we move forward, that idea is going to become more helpful each time. So if there's any questions about StatCrunch, number one issue is your pop-up blocker. Since it opens up a new tab or a new window, you got to make sure you allow the pop-up blocker to allow StatCrunch to be opened in a new tab. That's the most common mistake. So please check that as you're opening that, and I would encourage everyone to try some things out just to make sure you can get it opened up. And then as we move forward in the semester, we're going to be using that more and more. Have a good day, everyone.